So thanks everyone for joining. In the part one, we saw the basics of the models which are hosted on AWS. So you can see like AWS has their own Titan models. They have like this Nova models, and we saw like what are like locally hosted models on Olama. Using Olama, we can access those. What are they, and how do these cloud hosted models differ? Then we also saw about the basics of like prompt management. How can we write different prompts, compare them in this AWS Bedrock playgrounds and kind of version them so that we can use them later in our applications. We saw a little all about like how to log all these model interactions that we have so that we can have a good observability, and it's a whole transparent system about what calls are being made at the backend when we are executing a certain query. And finally we saw a code sample of how from Python code using Boto 3 AWS module can we query the models which we have got access to on AWS Bedrock. We also saw like how to request access on AWS Bedrock, and also saw in very brief what the AWS inference profiles mean. If you are not there for the first session, you can go back to the recording and check about all these things that we discussed. So now, today let's start with part two of our AWS Bedrock learning series, right? So today we are going to talk about RAG. So RAG is Retrieval Augmented Generation, right? And I'll explain you every part of this acronym. So at a very high level view, how does RAG work? If you can see this second image here, is you have a data source, right? So you take that data source. Let's say you have a file of 100 words, right? You take that file, you parse that file, then you divide that file into small pieces so that your LLM can understand it semantically, right? We call it as chunking. Once it's chunked, you also add like metadata information so that it's indexed, so that it's easier for your LLM to find that file, or when it's stored in a vector database, it can be stored at right indexes. Once we have done this ingestion pre-processing, we store that file into a vector database. So vector database, unlike your relational databases or your like your NoSQL databases, right? Vector databases are different. So your regular databases work on keyword searching, where you are like, hey, from XYZ table select where column equal to some value, right? However, vector databases work on the principle of semantic search, where you provide not keywords, but you say, hey, show me all the summerware, right? And once you say that, the what LLM or what vector database does, it is that it has stored all your source chunks that we created before into it has converted that into like numerical representations and stored in itself. Then there is a similarity search that happens at the vector DB level. Till now, LLM is nowhere involved. The similarity search happens in the vector database based on what user query is there. We get relevant chunks. So based on like summer weather, whatever is present in our source document, you will get that. That is added to the model context. So here we have completed the chunks retrieval part, right? Once the chunks are retrieved, and you already have the user query, then the LLM kind of looks at both and says that, okay, from the retrieved chunks, I think the answer to the user query is these three match as the answers, right? Because there can be multiple interpretations the LLM can do, right? And based on whatever filters that you have put, you can retrieve like top end results, right? Then you can also LLM re-ranking on these results, right? So based on how much confidence it has on its answers, it can re-rank these, and then the top rank will be given out as an answer. So this is retrieval part where you retrieve the chunks. Augmented is you augment your LLM's context or and your query with this particular retrieve chunks, and generation is you use all these to generate a response, right? as you might know, data is primarily in two formats, structured and unstructured documents. So structured is like your SQLs, right? Where data is already uh, stored
Oh,
in a tabular format, right? Where there are relationships existing between different aspects of that data, right? Like you have this foreign keys and then you create these joins. So the relationships already exist and it's easier to get data from these kind of already structured sources, right? However, when you have unstructured sources like your text files, your PDFs, which have like text, images, videos, audio, this is kind of an unstructured data. For that, we use something called as vector DB, right? We use something called as embeddings, where you have to first convert this unstructured data into a this numerical format which can be understood by your LLMs, right? There is more to it, but this is very high level at a simplistic view. Okay, so before we go to our demo, let us first go over the workflow of how does RAG look in AWS Bedrock, right? So first we will, as you saw in this picture, we have our data source, right? So in here we will have S3, Amazon S3, which is object storage as our data source, right? Then we will upload our private documents or the documents we want to ask questions about, our company documents, confidential documents, if they are, to our S3 bucket, right? Then we will come to AWS Bedrock. We will create a knowledge base, and this knowledge base can be attached to multiple data sources. As I said, it can be a structured data source or an unstructured data source. Today, we are going to look mostly in unstructured data source. And even in unstructured data source, you can attach it to S3. You can attach it to your Salesforce data if you want to. You can attach it to a Salesforce website. There are multiple data sources available, which you will see once we are at the demo. But here we will select S3 as our data source since we have uploaded data there already. Then we set these ingestion parameters that I just discussed, like the chunking strategy, what model you want to use for the whole process. What is the text embedding model? The text embedding model is similar to your LLM, but it specializes in converting uh, these like chunks of words into numerical representations and then store into vector database, right? Those are the ingestion parameters we set. Then we have to sync data. So we have data source, we created knowledge base, we set the ingestion parameters. Now we actually run the process of creating those chunks, embedding them, and storing in the vector database. At this part, we also select what kind of vector database we want to connect to. We have Amazon's own open search vector database, or you have uh, other commercial databases like Pinecone available that also you can connect. Once you sync the data, which means now the data is in the vector database, we will test that in our AWS Bedrock portal. And finally, we will look at the code sample of how can we query this data from a created knowledge base. Okay, so let's go to the demo. So I have this two data sources that I have. So I work for a company called as Keysight, and we have this product IX Network, right, which is a network testing tool. So this is the data sheet of that product, right? And my problem statement is that at end of these data sheets, there are these license numbers which are provided. So a lot of time customers come up to me and they are like, hey, can I have an MPLS license? Then I have to open this data sheet and control F and search through it, right? So I want a solution where I can just store this PDF as my knowledge source and then query it from my RAG application, right? And I'm ingesting two of these PDFs. So we have like a hardware solution and a virtual solution to do that. So I'm just gonna chat with my these PDFs using the RAG application, right? So let's go to my uh, browser. So if you see here, I have my S3 buckets here, right? I have this bucket IX network data sheets. These are the two data sheets I already showed you, right? Now that we have our data source created and we have files uploaded, let's go to AWS Bedrock. Have S3 bucket configured with our data sheets. Let's create a knowledge base which will uh, connect our data store, which is our S3 PDFs, and store it in a vector database, which we'll select when we will be creating this knowledge base, right? So go to your Bedrock, come to this knowledge bases here. Once you go to knowledge bases here, just call it whatever you want. I'll just call it knowledge base Ixia data sheets, right? And you'll fill in the other details. Let's create a new service role. Our data source is Amazon S3, so let's keep it that way. You can add a tag if you want. This log deliveries is if you want to do an additional analysis on how your databases are created or whatever is happening in your knowledge bases, right? But we'll leave it as it is for right now. So here is where we are specifying our data source. So let's call our data source as knowledge S3, right? So knowledge S3, where's the data source? This account. Let's browse it. Here we see that IX network data sheet. We'll select that, we'll choose it. We can leave the other stuff as it is. You can, as we discussed before, right? We chunk the data, right? We break the bigger document into smaller segments. So that logic, there are various ways that you can implement that chunking. Like default is you define it in like split the documents in 300 tokens. Usually this limit is chosen based on how much is the context window of your LLMs and how much you want to store it in the vector database, right? Because you have to split your document and then make the overlaps between these different chunks really wisely, so that contextually when the LLM or contextually when your application will try to get the similar chunks of stored vectors, they will get the relevant chunks, right? So there is a lot of selections or factors to consider when you're selecting a chunking strategy. You can go over these chunking strategies on your own after we on your own at your own time, but for now we'll select a default chunking strategy, right? We can leave the other settings as it is for now. You can add up to 5 data sources. So like you have one bucket with data sheets, you can have another bucket with say product specifications, you can have third bucket with say sales data. So all of these can come in and you can store it in your vector database. Embedding models. So as we saw before, embedding is something that converts your text into numerical representation, which can be then understood by your application, right? Which will do the retrieval, which will get the similarity chunks based on the similarity score, right? So Bedrock will use these embeddings to figure out what is the user query and what in the existing database is very close to this user query. Let's apply it. You have selected Titan text embedding. I'm not going to use an existing vector store. I'm just going to create a new vector store, right? So I want to select from Amazon's OpenSearch serverless, which is Amazon's own vector DB, right? Which is serverless. So that's pretty cool and pretty standard. So yeah, let's create the knowledge base now. Creation of knowledge base will take some time because it goes and does the whole ingestion pipeline that I showed you, right? So till the vector database gets created and the ingestion completes, let's move on to the code piece. Thank you. So if you go here and see, I'm going to explain two things, right? First is there are two APIs. The first is retrieve, right? And second is retrieve and generate, right? So this particularly addresses two aspects, as we said, right? First is where AWS Bedrock kind of uses the similarity algorithms and gets the similar chunks from the database is this retrieve part, right? So let's say you just want to use AWS Bedrock's functionality to get the similarity chunks, but you have some other system to actually generate the response using an LLM, because the LLM that you want to use is probably not hosted on AWS, right? So you can come write a code where you retrieve where knowledge base resides in AWS Bedrock. You retrieve the chunks from AWS Bedrock, but the generation part of it can happen using a different LLM. So this is how you do it. You define what knowledge base you have, the query, and you define how many top results, how many top similar results you want to get from that, right? Uh, so here, as you see, I requested licenses. As you remember in my datasheet, I have licenses for different families of my product, right? So I request that show me licenses for RS1 family and give some formatting, right? So then it will so this is for the actually retrieval and generation, but for retrieval I can just use this part where, right, okay, that show me licenses for RS1 family. So show me licenses for RS1 family, and this will give me like similarity chunks, right? And now when I go to retrieve and generate, as you can see here, the stark difference is in retrieve, there is no mention of LLM here because LLM is not at all involved. There are like similarity algorithms which are picking out those chunks, right? And AWS Bedrock is orchestrating that. However, when I generate it, I have my model ARN, which is my Amazon Noah Micro uh, model, right, that I'm using. That model accesses the knowledge base. It retrieves the similar chunk, uses those chunks in the context of the LLM, then takes the user query in, and based on that, it will generate and response for you, right? So these are the two main kind of operations that one does on the knowledge bases. You can also stream the output. So this guy will retrieve and generate will just give you output like a question and answer like all at once, right? However, if you want to have the functionality like chat GPT where it kind of streams the output, you can use that API as well. Now, so now as you can see, our vector database has got created at the backend. We are still creating the knowledge base and the execution role. As I was talking, everything is get now created. Now for the ingestion part, right? So knowledge base will select and we'll say sync. So what this will do is it will connect to your data source at the backend, which is your S3, and get the data stored into your vector database, right? This is a incremental synchronization. So only for the first time, if you have large number of PDF files, it will take some time. For next, let's say you update a PDF or something, or you add just one more PDF, the updates only will be synced, not the whole thing. So incremental updates kind of is a smart thing that a Bedrock has implemented too. So now let's sync our S3 to our knowledge base. So syncing has started. Okay, that was fast because we just had two PDFs, right? So now that sync has completed, our data is in our knowledge base. Now let's test it, right? So here we have various parameters that we can change to test out how our knowledge base model works, right? As you can see till now, uh, the ingestion part, there is no LLM involved, right? Even when you say retrieve only data sources where we are selecting the similar chunks of using logics like cosine similarity, AWS Bedrock will do that. There is no LLM involved. Where LLM is involved is taking those chunks, putting them into context, and then from context creating a coherent response for the user, right? That's where LLM will come into play. So let's do it both. Let's try both of these, right? So source chunks, I'm saying I want to just get like top 3 of the similar results, right? So let's keep it top 3. Search type, I'm just doing a basic semantic search. Here you can see there is an option between hybrid search and semantic search for better accuracy. You can explore these options. when you do actual hands-on. We can add guardrails which can say that, oh, if someone asks a question about Keysight's competition, give him a response that, I'm a Keysight bot, not the competition company's bot. So, or you can put in guardrails to avoid customer using abusive language or whatever, right? You can define your manipulable filters if you want. Okay, so now that we have our knowledge base, first just let's check retrieval data sources. So since I told you that I want to get similar licensing information, right? So let's say I want to get MPLS bundles for Aris1. Aris1 is one of our hardware that is in the datasheet. So I asked it and it came back with details, right? It was pretty fast. So if I go to details, as you can see, it gave me 3 top chunks here. So this was relevant, this was relevant, and this chunk was relevant. It found something related to MPLS here. Now let me take the same query and give it retrieval response and data sources and model. I'll select a model here. Let's know a Premier, apply, and now I'll put the same prompt. So it won't just give me the bundles, but it also gave me the exact part numbers, right? So if I can show you the details here, you can see the chunks as well. But along with that, it took all those 3 chunks. It kind of LLM did a understanding of them and came up with a result like, say, for MPLS and VPN package, if you are asking for MPLS, for this you should use a particular part number that I think is valid from the datasheet. So this is how your knowledge bases work. So just to review quickly, we created a knowledge base, we connected it to our backend data source S3, then we synced the data in our knowledge base, which kind of completed the whole ingestion process, and then we just tested our knowledge base, right? Now note that previously in our code example, the knowledge base's ID is this one, which is important, which will be used from code to kind of query this particular knowledge base. So yeah, this was the whole demo of AWS Bedrock knowledge bases. Thanks. Thanks for attending this part 2. Next time we'll move on to how to create agents in AWS Bedrock. Thank you.